Hi, welcome back to Chem with Go. Today we're going to take a look at the derivation of Graham's law of effusion. Now let's first define what effusion is. Effusion is the ability of a gas to escape through a pinhole, or from a container from a small opening like a pinhole. Thomas Graham actually theorized that the rate of the effusion of A divided by the rate of effusion of B is equal to the inverse square root of their molar masses. Now, the derivation of this comes from the idea that if both A and B are in the same container and they both happen to have the same temperature, they will have the same average kinetic energies. And it's from the kinetic energy equation that this comes from. Again, one more time. So that if I had gas A and gas B, the kinetic energy in the same container at the same temperature, that means that the average kinetic energy of A should be equal to the average kinetic energy of B. Now, from our kinetic theory of matter, okay, we know that the kinetic energy equation is equal to 1/2 mv squared. So let's substitute that equation into both of these kinetic energies right here. So let's go ahead and write that in. So this will be 1/2 m of A v of A squared is equal to 1/2 of the molar mass of gas B times the velocity squared. And that velocity is of gas B right there. Now, let's try to see if we can go ahead and cancel some terms out. Now, since we have 1/2 on both sides, we can go ahead and cross both of those out. It's like multiplying by 2 on both sides. So now we just have the molar mass of gas A and the velocity of gas A squared is equal to the molar mass of gas B times the velocity of gas B squared. And I think from here, you're beginning to see that we need to take the square root of both the sides in order for us to get to the answer. And then taking the square root of both sides will give us the inverse relationship between the molar masses. So let's go ahead and continue it on. So remember that rate, again, is just the, in this case, it would be the velocity of this particle to effuse, like to pass through that tiny opening. So why don't we go ahead and divide both sides by VB squared, okay, and divide both sides by MA. So let's write that out. So VA squared, okay, and this will be equal to, and I'll divide this by MA over here. And then let's go ahead and fill this in, MB, and this will be VB squared. And from here, what we need to do is take the square root of both sides, so the square root of this, square root of that. And that gives us, okay, the velocity of A divided by the velocity of B is equal to the square root of the molar masses, the inverse of the molar masses, so of MB divided by MA, which is Graham's law of effusion. All right, now, make sure that you guys study this derivation. I might probably show up on a quiz or on a test, or maybe on the final exam for the second semester. So again, Graham's law of effusion comes from the kinetic energy equation right here, and what we do is we do an algebraic manipulation to eventually get to this equation. All right, have a good night. I'll talk to you guys soon.